Okay, welcome, and today in this video we're going to start talking about quadratic equation. Okay, so what is a quadratic equation? So a quadratic equation is any equation that has what we call a degree of 2, or the largest exponent. So the term with the largest exponent is 2. Okay, has an exponent of 2. So this term here distinguishes it from other types of equations, and so quadratic equations must have this x squared term. Okay, if it doesn't have an x squared term, then it's not a quadratic. Okay, so that means a cannot equal 0, but b and c can equal 0. Okay, so you don't need these two terms in order to have a quadratic. For example, you could just have x squared, and that would be a quadratic equation. So if you had this, that would be a quadratic equation. If you had this, that would be a quadratic function, right? So again, just to be aware of what makes a quadratic equation, or a quadratic form of a polynomial. Okay, so again, let's get into the nitty-gritty. So if you have this is a quadratic equation. This is what we call a quadratic equation. It's got a quadratic expression on one side, 0 on the other. This is called the general form of the equation, quadratic equation. Okay. Also, this is called any expression that can be simplified into something that looks like this is called a quadratic expression in x, okay, or a quadratic equation in x. So it's got one unknown, which is x, okay. Now, if we write it as a function, so if we function equals this, a quadratic expression, we call that a quadratic function, okay. So very straightforward and simple. Excuse me. Okay. What kind of applications do these have? Well, think about parabolas. So the graph of a quadratic is either going to look like something like this, or it's going to look something like this. Okay? So, what sorts of things, applications fall into these types of graphs? Well, if we have a projectile, let's say you're throwing a rock, or a missile is launched in the air, or a bow and arrow, or a bullet, or let's say you have, so you'd have something like this in those cases. In this case here, you might have like a cost function where you're trying to minimize cost, or you're trying to minimize the area of a rectangle, or the volume of a box, and you're trying to minimize it, so it'll have this type of curve depending on the dimensions of the box, or the dimensions of the garden. Let's say if you're trying to find the maximum area of a garden, and you've got the width and the length of the garden, so you're going to have something that looks like this as far as trying to or look like this if you're trying to maximize the area of the garden, or if you're trying to minimize cost. Let's say you got two things that are behaving this way, that would be another application. So anything that has a parabolic shape to it can be represented using a quadratic function. Okay. Okay. So next time we'll go in and do some examples, and we'll go from there.